Now that we've practiced steps 1 and steps 2 for a two-proportion hypothesis test, it's time to practice step 3. Step 3 is where we calculate our test statistic, and in order to calculate our test statistic, the first thing we need to do is find SC. Now, the formula for SC is actually very similar to the one we have for confidence intervals, so I'll go ahead and write that over here. For a confidence interval, remember SC is equal to that giant square root, P1 hat, 1 minus P1 hat over N1, plus P2 hat, 1 minus P2 hat, all over N2. Now the difference between this formula and the one we want to use for hypothesis testing is that we're assuming P1 hat and P2 hat are not the best estimates. That is, we've actually made an assumption about what our proportion should be, and that is, we're thinking that instead of P1 hat and P2 hat, our pooled proportion is actually better. So all we do is we take that SC formula and we replace that P1 hat, that P2 hat, with our pooled proportion. So let's write it out. After we write it out, we'll go ahead and simplify it to have a nicer form. So replacing the P1 hat with pooled, all over N1, and the same with P2 hat. I notice that both of these fractions have exactly the same numerator. That is the same number on top. So what I'm going to do is I'm going to take that numerator and I'm going to factor it off of both of those. So I'm going to pull this off the first one and this off the second one. And when I factor that out, I'll have my pooled proportion, 1 minus my pooled proportion, and on top of that N1 will be just a 1. So I'll have 1 over N1 plus 1 over N2. And what this gives me is a much nicer formula. It's based on my confidence interval formula, so it's based on this. I replaced P1 hat and P2 hat with my pooled proportion to get this over here. And then I went ahead and factored off the pooled proportion to get my final formula right here. So this is the formula we'll go ahead and use for SC. Now that we figured that out, the only other thing I need to calculate is Z. Remember, Z is always my observed minus my expected or assumed divided by my estimate of my standard deviation. In this case, my observed value is the observed difference between the two, which means I'm going to take P1 hat minus P2 hat. That's my observed value, so that's what actually happened. I'm then going to go ahead and subtract off what I expect to happen. Well, we're assuming, according to our null hypothesis, that there's no difference. So if there's no difference, when I take P1 and I subtract P2, that should give me 0. So my expected value is 0. I then divide by my estimate of the standard deviation, which is SC. Now here's the nice thing, that when I go to subtract 0, subtracting 0 doesn't actually do anything, so I'm just going to go ahead and erase all that junk. And so what we have listed here are our formulas for SC, highlighted in blue, and then down here, the formula I will use for my Z-score.